Okay, so today we are going to talk about 4.3 and 4.4, and that's where we're starting to get into our medical stuff, or more into our medical stuff. I guess we kind of did some of it with the apothecary, but now we're getting into actual medical, like medication dosaging, and we're going to talk about syringes. And then next week we're going to talk about pharmacy calculations. So it's kind of like we're in this little medical bubble right now. So let me share my screen with you and we'll get going. So we've got medical orders and prescriptions contain the following. You've got your patient's name, the date, the name of the drug, the dosage, the administration route, the frequency, the duration, the quantity, if there's a generic substitute, the doctor's signature, and then the doctor's DEA number. And then we've got some necessary abbreviations. So these are things you should memorize. PRN means as needed. And so we're starting in 4.3, but in your textbook, if you look at, I think it's 4.1 and 4.2, there are huge lists of these abbreviations written out that you can look over to help familiarize yourself. BID means twice a day. TID means 3 times a day, or twice a day, thrice, I guess. We'll just go 3 times a day. Q2H means every 2 hours. Q3H means every 3 hours. And Q4H means every 4 hours. And obviously, if you had a Q6H, that would mean every 6 hours. Some other abbreviations that would be helpful to know. IM means intramuscular or into the muscle. IV is intravenous or into vein. Oh, I'm putting a G on the end of vein. Sub-Q means subcutaneous. So that would be into the subcutaneous tissue. AC means before meals. And PC means after meals. And so, like I said, in your textbook, if you look on pages 113 to 117, you are going to have a whole huge list of all sorts of abbreviations that you can use. So a physician writes the medical orders as follow: nitroglycerin, GR 1400, sub-L PRN. So we want to translate this into normal words. So the GR 1400 means 1/400 of a grain or grains of nitroglycerin. And then sub-L means under the tongue. Sublingual is also another way that you'll hear it referred to. So again, SUBL means under the tongue. And then the PRN means as needed. If I remember, nitroglycerin is given for heart attacks, maybe? I don't remember. Again, I know how to interpret these. I don't necessarily know what the drugs are used for. So again, we're going to give 1/400 grains of nitroglycerin under the tongue as needed. If we go to the next page, this is a continuation. It says, assuming only 0.3 milligram tablets are available, calculate 1 dose. So again, if I bring over what we have from the previous page, because this goes with that, we're doing 1/400 grains given as needed. So we're trying to actually, though, dispense this medication, but only comes in 0.3 milligram tablets. So that means we need to convert grains to milligrams. Excuse me. And if we look back at our notes from, let's see, what is it? 3.7, it tells us that 60 milligrams is equal to 1 grain. So if I convert grains to milligrams, I'm going to take 1/400 grains and I'm going to multiply it by so let's take the 1/400 instead of writing it as a fraction. Let's convert this to a decimal just to make our life a little bit easier. I'm going to do 1/400 equals 0.0025 grains. So we're going to take 0.0025 grains and write that over 1. And we're going to multiply it by a conversion factor that says 60 milligrams to 1 grain. So multiplying 60 by 0.0025, we end up with 0.15 milligrams. So now we know what the dosage is in milligrams, but then we need to know how many tablets to actually dispense. And so the tablets come in 0.3 milligrams. So we're going to take 0.15 milligrams and we're going to multiply it by 1 tablet over 0.3 milligrams, which is 0.5 tablets. Or half a tablet. Now we're going to assume that this tablet is able to be cut in half, meaning it's got a score mark, or else if it doesn't have a score mark, that means breaking it is not accurate. With the score, at least you can be more accurate. But again, that's more of these decide of what can you actually dose given what medication that's appropriate or available to you. Part 3 says how many tablets are needed altogether to fill this order. And because the order is as needed, we can't calculate the quantity. No, and that's not to say that if you were going to go into pharmacology and you would work as a pharmacy tech, that there wouldn't be an advice for how many to disperse in general for a prescription like this. But if given just the information that we have and we want to calculate how many tablets we need, again, we don't have enough information to calculate that. In number 2, it says our order is ampicillin, 500 milligrams, PO, QID, X feet 5D. What does this mean? First of all, PO means by mouth. QID means 4 times a day. And then X5D means for 5 days. So we're supposed to give 500 milligrams by mouth 4 times a day for 5 days. So if the dosage available is 250 milligram capsules, find the total given. So in order to find the total number of capsules that need to be dispersed, we're going to calculate 1 dose. And 1 dose is going to be 500 milligrams. And we're going to multiply it by 1 capsule over 250 milligrams. So this tells us how many capsules to give in a single dose, which 500 divided by 250 is going to be 2 capsules. Hold on 1 second. I'm just going to blow my nose really fast. Sorry about that. I have terrible allergies. So now we need to find the total that we need to disperse. So we're going to do 2 capsules per dose times 4 doses per day times 5 days total. And I'm just writing it over 1 so that I have, I can multiply those fractions all the way across, all across the numerator, all across the denominator. So 2 times 4 is going to be 8, and 8 times 5 is going to be 40. So we're going to need 40 capsules for this full prescription. All right, so I'm going to leave the information up above for number 1. And I want you to try number 2. So its order is Loratadine 10 milligrams, BID X5D, and the dosage available is 2 milligrams per milliliter syrup. So I want 2 things. How much is 1 dose in milliliters and total needed in milliliters? Go ahead and calculate that for number 2. If you have any questions, let me know. Send me your answers in a direct message for both of those, please. Okay, so if we look at one dose, so we're getting 10 milligrams BID, which remember BID means twice a day, for 5 days. And then the dosage available is 2 milligrams per milliliter. So one dose, we're going to take our 10 milligrams for one dose, and we're going to multiply it by our 1 milliliter over 2 milligrams. Now, with this type of ratio, we have 2 milligrams over 1 milliliter, or we can also do 1 milliliter over 2 milligrams because it's considered a unit conversion. They're equivalent to each other. And so depending on which unit of measure you're trying to cancel, that's which way you're going to flip your fraction. So because we want our milligrams to cancel, we would put the milligrams on the bottom. So our milligrams cancel. We end up with 10 over 2, which gives us 5 milliliters for one dose. To come up with the total needed in milliliters, excuse me, I'm going to do, so 5 milliliters over one dose times 2 doses in 1 day times 5 days over 1. Or you could write over total given or something like that. But again, we don't really worry about what the denominator is on that last piece, because as we move through, our doses will cancel, our days will cancel, and I get 5 times 2, which is 10, and 10 times 5 gives me 50 milliliters total is what we need. So going from dosaging, we're going to look at syringe calculations. Now, when we're dealing with syringe calculations, I have to preface this. I'm not a medical professional. I happen to be diabetic, so I use syringes in my personal life, but everything that I'm going to tell you has to do with just if in a fantasy world you were choosing a syringe and you were using the amount that you needed. I'm telling you how you would do that. Obviously, in the medical field itself, they're going to have different things available to you, all of those types of things. So I don't want you to say, well, Aaron said when you're in your medical classes, this is all purely just from a strictly math standpoint, okay? So when we look at syringe calculations, so hypodermic syringe is a medical instrument that is used to administer sterile liquid medicine or medications through the skin. Syringes are used in all of the peritoneal administration routes. In addition to standard syringes, there are specialized syringes such as insulin syringes, which are marked in USP units, tuberculin syringes, which have slim barrels and only hold 1 cc when full, and syringes that are pre-filled with exact amounts of medications. So if we look at the syringe, you've got your barrel that has the markings. This is a cc syringe. We can tell that right here. This is considered a 3 cc syringe. The hole marked, the 1 would be 1 cc, the 2 is 2 cc. It's also giving you the equivalents in minims. And so 2 cc's is going to be 30 minims. And then you've got your plunger, which you've got your top ring and your bottom ring. When you are measuring medication, you're going to measure to the top ring as to where it lies on your barrel. And then you've got your needle. And we've got some definitions. Enteral means esophagus, stomach, small, large intestines, i.e. oral. And parenteral or peritoneal is an injection or IV, for example, intravenous, subcutaneous, or intermuscular. When we think about the gauges of needles, the smaller the number, the larger the needle size is. So a 14 gauge is larger, where a 27 gauge is considered smaller. And larger needles tend to be longer. Your book has a typo on page 123, and it should read, the longer the needle, the larger the needle. You're going to use 5 to 20 cc syringes for IV infusions. And again, you measure at the top of the ring. Now, this diagram has all of our syringes laid out on it. This is a scan from your textbook. And so if I let's zoom out. So what I've got here is the images of the syringes on the left-hand side and the description of the syringes on the right-hand side. So syringes A, B, and C, which if you zoom in on these, A is a 20 cc syringe, B is a 10 cc, and C is a 5 cc syringe. They're considered large capacity syringes that are used to add medications to IV infusions. Syringe A is a 20 cc syringe calibrated in whole cc's. Syringe B is a 10 cc syringe, and syringe C is a 5 cc. Your book says that the marks are considered tenths, but there are only 4 tick marks between cc's, and so therefore it's calibrated in fifths of a cc or 0.2 cc's per mark. So D through H are for peritoneal injections. Syringe D is a 3 cc syringe and is calibrated in tenths, with the half cc marks in the larger tick mark. Syringe E is a half cc syringe. It's numbered in tenths of a cc. The large tick marks in each small mark is 1/100th of a cc. Syringe F is a tuberculin cc with a tuberculin syringe with a 1 cc capacity and is calibrated at hundredths. And then syringes G and H are for insulin only. So you've got a U100 insulin syringe, and that is to be used for injecting insulin only. It has a 1 cc capacity, and there's 100 units per milliliter. And then you've got syringe H, which is considered a low dose insulin syringe with a capacity of half cc. And again, the calibrated units is that there is a you've got 50 units per half cc. So what they're allowing you to do here is to be more accurate. So you can only give up to 50 units of insulin, versus with the U100 syringe G, you would give up to 100 units of insulin. So medication dosaging can only be as accurate as the syringe that is used. So a dosage amount is calculated to be 1.45 milliliters. If you use a 3 cc syringe, like D on the previous page, how should the dosage be rounded? So if we look at syringe D is a 3 cc syringe, and it's calibrated with tenths of a cc. So syringe D is only accurate to the 10th. So if we look at our example, the example says it wants to give you 1.45 milliliters, but the 5 is in the hundredths position, which means we can't be that accurate. And if we're going to use a 3 cc syringe, we can only go to tenths. So 3 cc is calibrated in tenths of a cc. Therefore, 1.45 milliliters becomes 1.5 milliliters. And you would also be giving 1.5 cc's for that. So if you look at, you would be given, because again, 1 cc equals 1 milliliter. So you would be giving that amount, which is as close as you can get. Okay. So number 2 says a nurse has chosen a tuberculin syringe to give an injection. Their calculations yield a dosage of 0.738 milliliters. To what place should they round the dosage to? So our tuberculin, if we go back to our previous page, a tuberculin syringe has a 1 cc capacity and is calibrated to hundredths of a cc. So the hundredths means that we can have 2 decimal places. So if we go back to our example, they've calculated 0.738 milliliters. So tuberculin syringe has a 1 cc capacity. And is calibrated to hundredths. So 0.738 milliliters can only be accurate to 2 decimal places, which means we're going to give 0.74 milliliters or 0.74 cc's. Okay. So number 3 says, what type of syringe would be appropriate to administer the following order and how much is administered? So we can give 200 milligrams intermuscular of a drug that has a concentration of 165 milligrams per milliliter. So if we think about our intermuscular syringes, which is going to be paired to like into the muscle. So we want to give 165 milligrams per milliliter. So we can use syringes D through F for those types of injections. Okay, so we can have a 3 cc milliliter syringe, a half cc, or a 1 cc. Those are our 3 options. So keeping those in mind, let's go calculate how much medication we actually have to give. So we want to give 200 milligrams of the drug. And we can use this concentration that's 165 milligrams per milliliter. Remember, so this is 165 milligrams over 1 milliliter, or we can use it as 1 milliliter over 165 milligrams. Again, we're trying to cancel the milligrams and get our quantity in milliliters. So we're going to use the second conversion factor. And if we divide those, meaning we multiply across, we get 200 over 165. We end up with 1.21 repeating milliliters. Okay. So we need to give more than 1 milliliter of drug, right? So the only syringe that we can use that'll give us more than 1 milliliter, if we go back to our previous page, the only one that's going to give us more than 1 milliliter, and we want to draw the entire medication in one syringe. We don't want to have to use multiple syringes. Therefore, we're going to use a 3 cc syringe, okay, which is calibrated in tenths of a cc, which means we can only be accurate to a tenth. So we're going to use a 3 cc syringe. And therefore, we can only give 1.21 when that's 0.21 repeating. That becomes 1.2 milliliters or 1.2 cc's. And so that's everything. Any questions before I let you go? So in my announcement, I did put that you've got your quiz 3 is releasing today. It is going to be due next week. And so you're going to want to have that get that done. Like I said, it's releasing today. It releases when lecture gets done today. What else do we have going on? Let me look at our course page. So tonight, we don't have any notes or anything due. Homework for 3.8 is going to be due Friday. Notes for what we just did today is due Friday as well. And then the quiz that releases today is due Wednesday. So that's everything you've got coming up. Okay. So I hope everybody has a good weekend. As usual, please email me if you have any questions. And I'll talk to you next week. Bye, everyone.